Welcome to Night Chemistry, your midnight laboratory of calm. Close your eyes and picture a winter evening in Michigan's Upper Peninsula, the sky dusted with starlight and the ground shimmering with fresh snow. A young boy named Glenn Theodore Seaborg stands beside a silent iron mine shaft, a chipped piece of or cupped in his mittened hands. He lifts the stone toward the moon, wondering what invisible energies might be sleeping inside. Draw in a long, steady breath. As you exhale, let the chill of that northern air melt into a gentle warmth that settles across your shoulders. Feel yourself drifting closer to Glenn's quiet curiosity, the question that will guide his entire life. What else is hidden in the heart of matter? Now imagine the scene changing. A westbound train slides through valleys and wheat fields, carrying the boy, now a lanky teenager, toward California. Golden sunlight floods the carriage, and each rail clack seems to whisper the names of places he has only met in books. Berkeley, Rad Lab, Cyclotron. With every mile, the periodic table in his pocket notebook feels less like a chart and more like an unfinished map waiting for new continents. Take another calm breath, slower this time. Notice how the rhythm of the rails becomes the rhythm of your own heartbeat. Steady, deliberate, unhurried. Feel the miles unwind beneath you, worries loosening like knots. As dusk gathers over San Francisco Bay, the train pulls into a station scented with eucalyptus and salt. Campus bells toll in the distance. Glenn steps onto the platform and pauses, sensing both excitement and the faint weight of responsibility. Somewhere beyond those bell towers, magnets the size of houses spin protons into brilliant arcs, and a new era of chemistry waits to be born. Breathe out gently. Let the echo of those bells fade until only silence remains, a silence wide enough to hold discovery, wonder, and rest. Tonight, we will follow Glenn Seaborg from snowy iron mines to glowing cyclotrons, past wartime secrets and into the quiet triumph of placing fresh tiles on the periodic table. For now, give yourself permission to lie back, release the day, and drift on the first soft currents of the story. The journey has just begun, and the elements are waiting. Iron mines and early sparks. Let your eyes grow heavy as the night drifts over Michigan's Upper Peninsula in the winter of 1922. Snowflakes spin like tiny crystals beneath a street lamp in the town of Ishpeming, their gentle descent softening every sound. A 12-year-old Glenn Seaborg steps from the warmth of a small wooden house, scarf pulled high against the cold. Each breath forms a brief cloud, then vanishes into the stillness. Pause here and draw one slow breath yourself. 4 counts in, hold. Then release over 6 counts. Feel the cool air of Glenn's world flow through you, clearing the static clatter of the day. With that exhale, picture every worry settling onto the snow, silent and harmless. Glenn's boots crunch over the packed path that winds toward the edge of the cliff's shaft iron mine. The head frames loom black against a sky powdered with starlight, yet to the boy, they are not relics of industry but portals to invisible realms. He slips a small cloth sack from his pocket and kneels beside a heap of tailings. Between gray shards he spots a glimmer of hematite laced with quartz veins. He gently pries it loose and holds it to the lamp. In the reflected glow he imagines suns blazing inside the stone, energies older than any story his teachers could tell. Another breath. 4 in, gentle hold, 6 out. As you exhale, allow your shoulders to ease, as though gravity itself has grown kind. At school, Glenn devours every book he can reach. Astronomy charts, mineral guides, stories of Marie Curie and her ghostly radium. Classmates trade baseball cards. Glenn trades tables of isotopes hand-copied from scarce journals. In the evenings he visits the public library, where a kindly librarian often finds him dozing over a chemistry text, thin fingers still marking a page. She places a knitted blanket around his shoulders, and Glenn wakes just enough to whisper thanks before plunging back into atomic mysteries. One Saturday the town's science teacher, Mr. Carlson, hosts a lantern-slide lecture on radioactivity and the new physics. The assembly hall smells faintly of coal and wood varnish. Glenn sits bolt upright in the front row, notebook ready. When slides of cloud chamber tracks appear, delicate white threads curving through darkness, his heart races. These streaks are proof of particles smaller than imagination, spirits dancing where no eye can follow. After the lecture, he waits until every adult has thanked the teacher and filed out. Then, voice quivering with both nerves and hope, he asks if radioactive atoms might be hiding in ordinary rocks. Mr. Carlson smiles, surprised by such a precise question from so young a pupil, and lends Glenn a dog-eared volume on nuclear disintegration. That night, long after lamps should be dark, Glenn copies diagrams beneath his blanket by flashlight, eyes sparkling brighter than the filament. Breathe again, slowly in and out. As the air leaves, sense the hush of a mining town after curfew. Distant whistles silenced, rails cooling, houses dimmed behind frosted panes. Within that hush a single mind hums, restless and awake. Winter turns to spring. Meltwater trickles along gravel streets, carrying flecks of red iron like secret runes. Glenn helps his mother plant rows of beans and carrots in the thawing garden, but even as he pats soil around fragile shoots, his thoughts orbit unseen atoms. He wonders whether sunlight touching the leaves might set off chain reactions too subtle for human senses, a private conversation between light and matter. One clear May afternoon, a parcel arrives from a cousin in Chicago, a crystallography kit of tin plate parts, glass lenses, and thin sheets of mica. Glenn assembles it on the kitchen table, aligning the lens so sunlight splinters into a faint spectrum across the wallpaper. He turns the dial and watches new colors bleed into view, proof that hidden structures within crystals bend light in ways textbooks promised but had never felt so immediate. His younger sister Louise claps in delight. Glenn only grins, already plotting experiments the kit's manual never mentioned. That summer brings sad news. The mine will lay off dozens, including friends of his father. At dinner, Glenn overhears hushed talk of families leaving in search of work. The boy presses a thumb against the meteorite-gray pebble in his pocket and vows, half prayer, half promise, that one day he will unlock riches no recession can touch, the riches of knowledge. Another breath, 4 in, hold, 6 out. Feel the resolve settling in your own chest, steady and quiet, like a lantern guarded from the wind. September's first frost silvers the pumpkin patch when a telegram arrives from his uncle in Los Angeles, offering a spare room and the chance for a better education. Glenn helps his mother fold sweaters into a battered suitcase, each crease smoothed with care. On the day of departure, townsfolk gather at the small station. Mr. Carlson presses a fresh periodic table leaflet into Glenn's hand and says, "Find what's missing." The boy nods solemnly, recognizing in those 3 words the permission to dream beyond any known element. Steam billows as the train pulls away. Glenn leans from the window, waving until the last pine slips from sight. In his lap rests a composition book already scribbled with speculative notes. Elements beyond uranium? Hypothesize new row beneath lanthanides. The ink is shaky, but the idea is bold. One final, unhurried breath. Let the rhythm of steel wheels echo inside you. With each gentle sway of the carriage, imagine pages fluttering forward in Glenn's life, toward cyclotrons, secret laboratories, and a future where blank spaces on the periodic table will bear names no human has yet spoken. Settle deeper into your pillow as the rails carry the boy westward through the night. The map of matter is about to expand, and you are drifting at the very edge of its unfolding horizon. Berkeley and the cyclotron awakening. The train sighs to a halt beneath the tall palms of Oakland Pier, and morning light pours across the platform like molten gold. Glenn steps down, suitcase in one hand, notebook in the other, and inhales a scent he has never known. Briny bay air laced with eucalyptus and distant blossoms. The clang of a cable car bell drifts over roofs as if ringing a promise, This city will reshape him. He rides an open tram through narrow streets, past bakeries setting out fresh loaves and newsboys calling headlines about distant storms on Wall Street. Every hill crest reveals quicksilver glimpses of the bay sparkling below, and for a heartbeat Glenn feels he is floating above the whole Pacific, as weightless as a thought. Sather Gate rises ahead, its oxidized copper glowing a soft sea green. He steps beneath the arch and onto the Berkeley campus, where oak leaves tremble in a gentle breeze. Stone facades carry sun-warmed echoes of conversations in dozens of languages. Here ideas migrate like birds between seasons, never lingering long before taking wing again. Glenn's first lecture is in a cavernous hall that smells of chalk dust and polished wood. Professor Gilbert N. Lewis sketches ionic bonds with brisk strokes, the white lines gleaming against the slate like constellations. Glenn transcribes every word, but the real revelation is the pause between concepts. How Lewis gazes at the diagram, brows knit in quiet wonder, as if even a master can still be surprised by the elegance of matter. Glenn tucks that memory away like a compass. After class he explores the radiological laboratory perched on an oak-covered hillside. The building's windows blink with reflections of sun and shadow. Unseen within, magnets roar softly like distant surf. At the entrance he meets Ernest O. Lawrence, tall, quick-smiling, coat pockets bulging with scribbled calculations. Lawrence ushers the young student inside to see the pride of Berkeley, a 37-inch cyclotron whose copper Ds glow under flickering arcs of violet light. The air vibrates faintly, not loud, yet alive with energy circling invisible paths. Glenn stands transfixed. He imagines protons whirling faster than thought, slamming into targets 1,000 times each second, cracking nuclei open like geodes and spilling secret jewels of new elements. For years he has studied diagrams. Now the machine that can redraw those diagrams rises before him like a steel sunrise. In the evenings, he finds a room in a plain boarding house on Durant Avenue. Its window looks onto a narrow alley of flowering plum trees. He pins a blank periodic table over the desk, space enough for dreams. Nights stretch long, but he is never lonely. Pages of equations pile around him like friendly snowdrifts, and each solution opens a corridor to a deeper question. One October dawn, campus lawns shimmer with dew. Glenn hurries uphill, coat flapping, pockets clinking with glass vials borrowed for an unsanctioned experiment. Inside the lab, senior researchers have retired for coffee. The cyclotron chamber is momentarily dark. He slips a tiny aluminum foil square onto the target holder, then lowers the vacuum hatch with hands that tremble only a little. When he powers the magnets, the room vibrates, softly at first, then with an insistent hum that seems to synchronize with the pulse in his wrists. As the beam dances, Glenn adjusts dials by instinct, like a pianist discovering a new chord. He mouths silent counts of beam current and exposure time, imagining every ion spiral, every collision's faint spark of transmutation. When the run ends, he waits the required minutes, then lifts the foil with tongs and slides it into a zinc sulfide screen. Tiny flashes bloom, pinpricks of green light, proof that atoms have changed their nature in the dark. He sits back, exhales, and in that release feels a boundary inside his mind dissolve. The periodic table is no longer a finished monument. It is clay, and the cyclotron is his wheel. Days become brisk with bay winds, and clocks seem to race the sunsets. Glenn moves through each hour with purposeful ease. Daylight classes, late afternoon lab shifts, midnight calculations. Yet he keeps one ritual. Just before dawn he steps onto the dormitory roof. The city below lies hushed. Only foghorns murmur across the water. He closes his eyes, inhales the cool salt air, and pictures unseen isotopes drifting on the breeze alongside gulls. Some will heal tumors. Others will illuminate the workings of stars. Each possibility feels like a secret lantern glimmering toward distant shores. Examinations come and go. He passes with ease, but grades feel trivial beside the exhilaration of discovery. One winter night he shares coffee with Lawrence in a cluttered office, chalk diagrams crowding every wall. They discuss rumors of an element beyond uranium, one briefly glimpsed in European labs yet not fully proven. Lawrence sketches orbital overlaps, Glenn counters with decay chain hypotheses, and together they hatch an audacious plan: bombard uranium with high-speed deuterons and trap whatever ghostly fragments emerge. The elder scientist's grin widens as he clasps Glenn's shoulder. Permission granted. Walking back through silent corridors, Glenn hears a new cadence in his footsteps. It is not arrogance but belonging, the subtle certainty that he will help solve this riddle. On his desk, the blank spaces below uranium seem to stir, like uncharted islands revealed at low tide. Before sleep, he writes a brief letter to his mother, telling her only that the university is challenging and wonderful, that he has found mentors who believe the impossible is merely unattempted. He signs off with gratitude, folds the sheet, and places it beside the periodic table. Then he dims the lamp, stretching out beneath a window where Orion climbs the sky. In the hush between heartbeats, he senses atoms decaying millions of times per second somewhere below, each decay a whisper saying, "Look closer. Drift with him now." Let the night carry both student and listener into a gentle darkness where questions glow like embers, and dawn waits just beyond the cyclotron's hidden orbit. Actinide revelation. Night drapes itself over the Berkeley hills in March of 1940, and the radiological laboratory sleeps beneath a thin mist. Only a single third-floor window glows, an amber rectangle cut into the darkness. Inside, Glenn Seaborg bends over a stainless steel fume hood, his tie loosened, his coffee long gone cold. 5 small beakers stand in a neat row, each labeled with a penciled 93. Tiny specks the color of wet sand swirl in their depths, suspended like wandering constellations. He lifts one beaker toward the lamp and studies the subtle tint of its nitrate solution. By every rule of the periodic table, element 93 should imitate rhenium or manganese, silvery, reluctant to dissolve, stubborn in its chemistry. Yet the liquid in Glenn's hand behaves more like uranium's gentle cousin, drifting toward an unexpected shade of pale peach. Notes from the day's separations confirm the puzzle. Exchange columns that easily tease out molybdenum refuse to budge this newcomer. Ions slide instead where thorium would, calm and unhurried. Outside, the campus bell tolls midnight. Glenn brushes chalk dust from his vest and crosses to the blackboard, where a familiar grid of elements waits. He touches the square for uranium, atomic number 92, then the blank square beside it. Neptunium, he murmurs, the name recently suggested by Edwin Macmillan after Neptune, the planet beyond Uranus. But names alone cannot mend a fracture in logic. If 93 does not resemble the elements above it, perhaps the table itself is misdrawn. He remembers childhood evenings in Eichbeming, rearranging iron filings on paper to see hidden patterns in magnetic fields. Tonight he approaches the periodic table with the same restless curiosity. Chalk in hand, he sketches the lanthanide row, cerium through lutetium, then drops his line straight down beneath thorium. What if 93 belongs here, he wonders, not in group 7 but in a new horizontal family that mirrors the rare earths. A clock ticks. No other sound intrudes. He writes actinides. Above the fresh row, the letters slanting slightly from haste. The very act of naming releases a quiet thrill that ripples through his chest. Actinium, thorium, protactinium, uranium. The cadence feels inevitable, as though the table has been waiting for someone to notice its missing echo. He pulls a blank index card from his coat and begins to map beyond what is known. 93 Neptunium, 94 Plutonium, 95. No name yet. 96, 97, 98. Each number opens a door onto a room still dark, but he can almost sense the furniture of their chemistries. He pencils tentative oxidation states beside them, little question marks floating like lanterns. Take a slow, gentle breath with him. 4 counts in, pause. And exhale over 6. Feel the mind settle into that hush where unlikely connections appear, bright as meteors against a winter sky. The laboratory air grows chilly. Even the constant hum of the building's transformers seems to dim. Glenn rubs his eyes, then resumes comparing column after column of data. Half-lives measured in hours instead of centuries, emission lines inching toward the ultraviolet, strange beta energies that refuse to match predictions. Gradually the numbers coalesce around a single conclusion. These new nuclei are not eccentric members of an old family. They are founders of a lineage all their own. At 2 in the morning he steps onto the fire escape balcony for a lungful of damp night air. Below, eucalyptus branches sway, scattering beads of mist that glimmer in the street lamps. He imagines the hidden atoms inside those leaves. Carbon, hydrogen, oxygen, so modest beside uranium's colossal heart, yet all are threads in the same cosmic tapestry. Somewhere, perhaps in another galaxy, beings may be forging elements past 106, past 110, continuing the pattern he has just glimpsed. The idea feels both gigantic and strangely intimate, as if the universe has leaned close to share a confidence. Another breath, in, hold out. Let the cool air glide through you, sweeping away any remaining restlessness. Back inside, Glenn drafts a memorandum to Lawrence and Macmillan. His fountain pen scratches steadily across the paper, outlining evidence that element 93 behaves like a miniature uranium, not like rhenium, that a theoretical 5F subshell, analogous to the 4F subshell of the lanthanides, must open just beyond actinium, that a new actinide series will reconcile the chemistry of transuranic elements with observed decay chains. He hesitates only once, wondering if he sounds presumptuous, then underlines his central sentence for emphasis. The anomalies vanish if we position elements 89 to 103 beneath the rare earths. He dates the page, signs it, and slips it into a drawer for dawn delivery. For a moment he simply stands, fingertips resting on the wood, sensing the fragile stillness that follows the birth of an idea. It is the same stillness that envelopes a snowfield after the wind stops, a hush so deep it seems to contain every future footstep. Fatigue seeps into his limbs at last. He extinguishes the lamps, leaving only the chalkboard illuminated by streetlight filtering through the blinds. The newly drawn row of actinides glows faintly, chalk particles catching the beam like dust in a sunshaft. To Glenn's eyes the board resembles a star chart, each element a distant point of light already sending its message across space and time. He gathers his coat, pauses, then reaches into the pocket for the piece of hematite he carried from Michigan. Its cold heft reminds him of beginnings, a boy beneath a mining lamp, dreaming of energies asleep in stone. He closes his fingers around the mineral, feeling the loop now complete. Curiosity leading to study, study to experiment, experiment to revelation, and revelation back to wonder. As he locks the lab door, dawn's first pale glow brushes the eastern horizon. Somewhere down the corridor, a janitor hums softly while mopping a stair. The world is stirring, yet Glenn moves through it as though encased in calm light. He knows the day will bring debate, calculations, perhaps skepticism, but the core insight will endure. The periodic table has flexed, making room for 9, 10, a dozen unseen companions, and his mind already reaches toward them with open hands. Breathe one final time, slowly, deeply. Picture the chalk row settling into permanence, the question marks shining with quiet promise. Let any tension in your own body drift away like eraser dust on a morning breeze. The shape of knowledge has widened, and within its new contours there is space for both discovery and rest. Step softly with Glenn into the corridor's dim hush. Ahead lies the task of proving what intuition has glimpsed. Behind stretches a path lit by iron mine lamps and cyclotron arcs. And beneath it all hums the gentle certainty that mysteries yield to patience, that blank spaces invite names, and that even the heaviest atoms begin as the faintest spark in a curious mind. Plutonium and the Met Lab. Winter dusk settles over San Francisco Bay in December 1941. Newspaper stands spill headlines of sudden war across two oceans, their bold type casting long shadows on the sidewalk. In a quiet chemistry office high above the campus, Glenn Seaborg folds one of those papers and presses it flat beneath a stack of notes. He has just confirmed that bombarding uranium with deuterons yields a second child of the actinide insight, element 94. Its fleeting X-ray fingerprint gleams on photographic film like a comet tail. He and Arthur Wall have already whispered a name drawn from the farthest planet then known, Plutonium. Take a slow breath. 4 counts in, gentle pause, 6 counts out. Feel the stillness of that moment before new duty sweeps him away. Within days, a discreet telegram arrives from the Office of Scientific Research and Development. It instructs Seaborg to leave Berkeley quietly for a secret project in Chicago. No details are offered, only a rail ticket, an address that does not appear on public maps, and a promise that his work could shorten the war. Sleepless the night before departure, Glenn walks the deserted hallway outside the cyclotron vault. His hand brushes the cool brass railing as he passes the control console. Lights dimmed, magnets silent, yet the room feels alive with unspent possibility. Pausing at the chalkboard, he traces the curve of the actinide row one last time, then closes his notebook and slips it into a leather valise. The train east rattles across snow-laced plains beneath a sky of frost-pale stars. Glenn shares a sleeper car with clusterings of engineers and physicists, each claiming to be headed for consulting work. Soft murmurs drift through the corridor after lights out, but no one names their destination aloud. Instead they speak in coded fragments, cross-sections, chain reactions, piles, hot chemistry. Glenn keeps mostly silent, gazing past the window at ribbons of moonlit snow, wondering how many neutrons it takes to bridge the distance between knowledge and ruin. Breathe in and out. Let that steady rhythm carry you along tracks that shimmer like mercury under the moon. Arriving in Chicago, he is ushered through service tunnels to an anonymous wing of the university, the Metallurgical Laboratory, or simply Met Lab. The building smells of machine oil and damp brick. Rooms once meant for lecture halls now bristle with graphite blocks, cadmium sheets, and counters ticking softly like distant rain. Men and women in wool overcoats hang black drapes across windows, a theatrical gesture that turns daylight into perpetual twilight. Glenn is assigned a basement suite of rooms labeled only Chemistry Group B. Inside, benches hold flasks tinted pale rose and amber by trace plutonium salts, radioactivity so intense that a pinch unseen to the naked eye can warm its own vessel. Every movement here is deliberate. Pipettes cradle micrograms that laboratories 5 years earlier would have called impossible. He meets Theodore Ted Magel, a soft-spoken radiochemist with an easy laugh, and Burris Cunningham, whose steady hands seem carved from oak. Together they pilot separations never attempted at such precision. Plutonium teased from vats of irradiated uranyl nitrate, coaxed through columns of ion exchange resin finer than beach sand, then plated onto tiny platinum discs for alpha counting. Each success is measured not in grams but in microcuries, a new arithmetic where power hides in weightless whispers. Mid-January brings blizzards that rattle window frames. Steam pipes clank through the night while Glenn scribbles decay curves under the dim glow of a shaded lamp. The lab air stays warm, yet he feels an inward chill whenever he recalls why the Army quartermaster keeps phoning for reports. These glowing flecks are destined not for healing tumors or tracing blood flow, but for a device whispered to split a city open like a geode. Draw a breath, 4 counts in. Hold, 6 counts out. Let the weight of that knowledge settle. then drift like snow beyond a pane of glass. One evening Enrico Fermi descends the stairs, coat still dusted with graphite from the experimental pile. He is building under Stagfield's abandoned squash court. He and Glenn share weak coffee at a cluttered desk, trading notes on neutron capture probabilities. Fermi's eyes beam with the joy of a chess master parsing a daring gambit, yet a crease of sorrow etches his forehead whenever conversation pauses. The two men fall silent at last, listening to the low hum of air vents. Each wonders how history will judge these hushed calculations. Weeks flow into months. Under the stadium bleachers, the first self-sustaining chain reaction flickers to life on a gray December afternoon. Glenn and his team stand in distant offices, ear pressed to a telephone receiver, as Fermi's voice calmly announces, "The reaction is exceeding 1." Applause erupts, then fades as everyone remembers what that single integer implies. Back in Chemistry B, the push intensifies. The War Department needs at least 6 kilograms of weapon-grade plutonium, a figure that feels unreal beside the milligram discs resting on Glenn's bench. To meet the demand, the team innovates continuous flow precipitation, devises high-temperature fluorination retorts, and drafts blueprints for a plant that will rise beside Columbia River Rapids in faraway Hanford. Glenn marks each breakthrough on his wall calendar, circles growing ever closer to a date he cannot name aloud. When exhaustion looms, he recalls a letter from his mother tucked in a desk drawer. She writes of California's orange blossoms and asks if his work is going well. Glenn folds the paper gently, unable to explain that he mixes solutions wearing leaded gloves thick as winter mittens, nor that the glow at the bottom of a beaker sometimes seems to pulse like a living heart. Another calming breath. Slow inhale, and release. Allow tension to wick away as quietly as steam from a kettle. Spring returns to the Midwest. Outside the Met Lab lilacs bloom, their scent drifting through loading bays stacked with lead bricks. On a rare Sunday furlough, Glenn crosses the Midway Plaisance and watches children sail toy boats on the lagoon. Sunlight flickers across the water, mirroring the speckled film badges he and his colleagues wear near their chests. He wonders if those children will grow up under skies forever altered by what this team may unleash. That evening, back in the basement, the first true gram of purified plutonium rests inside a nickel-plated capsule. It feels heavier in his palm than any metal should, not by mass but by meaning. He records its assay value, locks it in a steel safe, and writes a single line in his notebook. Power beyond imagining, entrusted to imperfect hands. As midnight nears, he climbs the stairs to the roof, a vantage point overlooking Chicago's grid of amber street lamps. Wind sweeps off the lake, cool and bracing. Glenn closes his eyes and pictures the periodic table expanding again, this time not with gentle chalk but with the hard thunder of possible futures. In one vision, reactors light entire continents. In another, cities vanish in a flash. Both outcomes spin together like isotopes in a centrifuge, inseparable for now. Breathe once more. Deep, slow, unhurried. Sense the night air across your skin, and with each exhale allow any lingering unease to soften, like snow melting at dawn. Stepping back inside, Glenn descends the stairwell, the safe humming faintly behind its heavy door. The corridor lights dim to conserve power. Work will resume at first light. More columns to load, more measurements to log, another sliver of the unknown coaxed into view. For you, listener, the hour has grown late as well. Let your own thoughts settle beside Glenn's locked capsule. Quiet, motionless, waiting only for the promise of morning insight. The story continues, but for now, drift gently, knowing that even in secret basements of wartime, wonder and conscience can share the same steady heartbeat. Trinity Dawn. July darkness clings to the windows of a cramped Chicago office, the hour just past midnight on the 16th day of 1945. Glenn Seaborg sits alone at a scarred wooden desk, a black telephone centered before him like an oracle. Its handset rests on a folded map of New Mexico, The Jornada del Muerto, the Journey of the Dead Man. An ancient desert basin now hosting the first full assembly of the device his laboratory has fed for 4 relentless years. Outside, the city is hushed beneath summer humidity. Street lamps halo in the damp air. A lone streetcar rumbles 2 blocks away, its clang softened by the thick night. Glenn loosens his tie, rubs his eyes, and glances at the waiting receiver. Somewhere 1,000 miles southwest, technicians thread cable through sandbags, adjust lens reflectors, and retreat to bunkers carved into ancient lava flows. In less than an hour, a sphere smaller than a basketball will decide whether theoretical calculations and fearful hopes align. Draw 1 steady breath. 4 counts in, gentle pause, 6 counts out. Let the hush of pre-dawn settle through your shoulders, as if you too are perched at a quiet desk while the world balances on a single moment. On the blotter lies a sheet of paper headed, Yield Predictions. 3 inked columns list megaton equivalents, each circled in pencil. Fermi guess, beta guess, Seaborg guess. The numbers trail off beneath a question mark. No one is certain. Glenn taps the eraser of his pencil against the page, remembering the day he purified the first gram of plutonium, watching violet light sparkle in its ionization chamber. Tonight that same metal waits inside a hollow core of explosive lenses, quiescent yet coiled with equations. Minutes creep past. The office clock's second hand ticks with exaggerated patience. Glenn stands, stretches, and steps to the window. Across the Midway Plaisance, Gothic towers blur against a humid sky. Fireflies dance among hedges, unaware that a false dawn may soon bloom in another state. He presses his palm to the cool glass, half wishing the test might fail, half praying it succeeds quickly so nations can learn the scale of their new responsibility. The phone rings. Its bell shatters the quiet, a single sharp trill that stills his breath. Glenn lifts the receiver. Static crackles like dry grass. A coded voice, a liaison officer whose name he never learned, speaks in clipped syllables. 0-5. Then a hollow pop of the line closing. Nothing more. Glenn returns the handset to its cradle and exhales. He imagines the desert plain. Black lava ridges, yuccas rigid under starlight, rain-filled arroyos twisting through dust. The bomb tower stands 100 feet tall, cables descending to bunkers where physicists crouch behind thick shutters. Some clasp clipboards, others pray. He hears none of it, only sees the scene through memory fragments of briefings and diagrams. For long minutes, he sits again, fingertips pressed to temples. The silence expands, dense, almost palpable. His mind drifts to Eichpeming nights, to glowing cloud chamber tracks that once seemed wondrous and harmless. He recalls the faint warmth radiating from a speck of plutonium cupped in a nickel spoon, marvel turned menace within a single war-torn decade. 3 minutes. A solitary car roars down Ellis Avenue, headlights sweeping across the building's facade before fading. Glenn pictures a faraway fuse sputtering toward implosion lenses. He envisions shock waves converging inward, forcing a tiny metal sphere to a density no planet has ever known. Will the nucleus divide cleanly? Will neutrons multiply fast enough? Theories tighten around possibility like ribs around a held breath. 2 minutes. He thinks of the people still asleep in nearby farmhouses outside Alamogordo, children drowsing beneath thin cotton sheets, ranch dogs curled on porches. They will not awaken until a silent flash floods their rooms brighter than noon. What will they dream in that instant of unnatural dawn? 1 minute. The office clock drones on, indifferent. Glenn folds his hands, palms humid. Somewhere a relay clicks. The phone line opens again, its rustle faint like wind over paper. A voice whispers a final code. 0. Silence. A heartbeat more. Then through the earpiece bursts a surge of static so loud he flinches. It rises, plateaus, and collapses into ghostly silence. For a moment he wonders if the instrument has failed. Then, through residual crackle, he hears the liaison's voice, hushed, awed. "The sun has risen twice." The line goes dead. Glenn lowers the receiver, pulse thudding in his throat. He leans back, staring at the ceiling where in dim light a plaster crack traces a jagged path, an accidental reminder of fissures now ripped across human history. No cheer escapes him, no cry of triumph. Only a long breath, slow and deliberate, as though he must relearn the rhythm of simply being alive. Take that breath with him now. Draw the air deep, hold briefly, and let it leave you without haste. Feel any tension soften, the way desert thunder rolls outward until it is memory. He stands, crossing to the window once more. Chicago remains unchanged. Fireflies flicker, leaves rustle, electric streetlights hum, unaware that somewhere the night sky turned briefly into magnesium daylight. Glenn closes his eyes and sees after images. Violet glare, molten clouds, a towering column of dust climbing beyond sight. Overlaid upon that vision is the image of a periodic table, its actinide row complete to plutonium, an accomplishment forever braided to a detonation. He walks to his desk and circles the middle number on the yield sheet, then lays down the pencil. Next he opens a blank page in his laboratory notebook and writes a single sentence. "We have split the world." Below it, in smaller print, he adds, "May it mend faster than it breaks." Footsteps echo in the corridor, messengers delivering news to other offices, other tense listeners. Glenn remains where he is, allowing the sounds to pass like a breeze. He knows that within hours telegrams will summon him to Washington, that committees will convene to discuss targets, timetables, ultimatums. For the moment, however, the room holds only quiet and the faint odor of machine oil. Breathe once more, slowly in, softly out. Imagine rays from a second sun fading back into night, leaving stars unchanged, leaving crickets singing again over cooling sand. Let whatever unease lingers in your chest dissolve like smoke in wind. When the telephone rings again at dawn, it will carry data. Blast pressure, luminosity curve, isotope ratios. Glenn will record them meticulously, as he always has. But for this fragile slice of pre-dawn, he simply watches darkness regather outside, enlivened by the distant wail of a freight horn. It is a sound from another age. An age that has, in the span of one blinding instant, slipped quietly behind the horizon. Settle deeper into your pillow as the city's quiet returns. Ahead lie decisions, protest, reconciliation, and new science that might yet harness these forces for healing rather than harm. For now, rest in the calm between thunderclaps, knowing that even in moments of overwhelming power, the heart can choose stillness, and the mind can choose hope. Rising tide of new elements. The war has ended, but the Met Lab's corridors still hum with late-night urgency. It is autumn 1945, and Glenn Seaborg stands in a narrow hotel room 3 blocks from the White House, a makeshift lab spread across the dresser. A single desk lamp illuminates a porcelain dish no wider than a teacup. Inside, an almost invisible speck of freshly separated element 95 rests on filter paper. Glenn flicks the wall switch. The room lights dim, yet faint sparks bloom in the dish, tiny green pinpricks against the dark. He lifts a zinc sulfide screen so the aides from the War Department can see. Their expressions shift from skepticism to wonder as each flash marks an alpha particle's brief signature. Glenn explains that this substance does not occur in nature. It was born when plutonium captured neutrons deep inside the Chicago piles. He pauses, then offers its proposed name, Americium, for the continent that marshaled minds and machines to create it. The aides nod reverently, as though glimpsing a new flag unfurled at the frontiers of matter. Breathe in slowly. Let curiosity fill the spaces behind your eyes, and breathe out, feeling the room's hush surround you like soft velvet. 2 months later, back in Berkeley's Gilman Hall, Chilled rain taps the sash windows while Glenn and chemist James Kennedy guide alpha counters toward peaks neither has seen before. The sample is element 96, formed by bombarding plutonium with alpha particles in Lorentz giant cyclotron. Its activity outshines Americium, a muted glow sealed behind celluloid. When the calibration settles, the trace belongs to a nucleus of 244 protons and neutrons, so new it has no entry on any chart. Glenn writes the name Curium across his lab book, honoring Pierre and Marie Curie, whose own search once turned pitchblende into scientific gold. Within weeks, the actinide row stretches farther. Berkelium emerges from a cocktail of accelerated helium and americium targets. Element 97 named for the city that shelters their cyclotron domes and fog-swept libraries. Soon Californium follows, element 98, its fleeting atoms wrung from furious currents of 60 MeV alpha beams. Each discovery feels like threading a needle in a hurricane, yet the needles keep appearing, glittering, impossibly sharp. Pause for another breath. Steady, unhurried. Let the thought of brand new names settling onto blank squares bring a quiet glow to your own imagination. Outside the lab, the world rushes toward mid-century optimism. Neon signs blaze, jazz horns climb stairwells, and headlines tout miracle plastics and jet planes. Inside Gilman Hall, late evenings echo with softer triumphs. The click of Geiger counters, the whisper of pipettes, the rustle of notebooks where equations race ahead of sleep. Glenn's team works in playful competition with laboratories at Argonne and Oak Ridge, mailing sealed envelopes to the journal Physical Review so that priority can be stamped in print before rumors travel too far. One night, an exhausted graduate student, eyes ringed with chalky fatigue, asks Glenn whether the table might truly be infinite. Glenn smiles, remembering the iron mine nights of his boyhood. He replies that the table is a ladder whose top is hidden by clouds. Each new rung is slippery, yet every ascent sharpens human patience and widens human hope. The student nods, pocketing that thought like a talisman. Weeks blur into seasons. In conference rooms across the country, committees debate security classifications, medical potentials, reactor designs. Glenn shuffles between hearings, lectures, and his cluttered office, always returning to the chalkboard where actinide symbols now flow like a river beyond plutonium. MSIM-BK, CF. He traces them with a fingertip, feeling the silent music of order restored. Draw one last breath with him, deep, measured, then let it travel outward, carrying away the day's noise. Imagine those 4 new squares anchoring the lower row of the periodic table, fresh ink drying into permanence. Side April rain clears. The moon rises over the bay, its pale face mirrored in laboratory windows. Glenn steps onto the balcony, slips a Geiger badge from his lapel, and watches it faintly tick in the moonlight. Behind him in the darkened lab, Americium glows on a shelf no bigger than a child's toy box, yet promises smoke detectors and pocket neutron sources. Curium hums with future space batteries. Berkelium whispers of breeder fuels. Californium dreams of probing oil wells and lighting neutron lenses. The elements have multiplied, and with them the stories matter can tell. Let that widening horizon guide you toward restful thought, a quiet procession of symbols drifting like lanterns across a calm night sea. MCM-BK-CF, each one born from the spark of human curiosity, each one a softly glowing star in the ever-expanding sky of knowledge. Steward of the atom. Morning sun slants across the Potomac as a black sedan glides through the gates of the Atomic Energy Commission. Glenn Seaborg, now gray at the temples yet quick in step, buttons his jacket against a brisk February breeze. It is 1961, and the newly sworn-in President John F. Kennedy has invited him to chair the nation's atomic future, a task as vast as any periodic table, yet resting squarely on one pair of shoulders. Pause for a calm breath. Draw air in, gentle and deep, then let it drift away until only ease remains. Inside the paneled conference room, maps unfurl across polished oak. Reactor sites, fallout patterns, test ranges half a world away. Around the table, Generals speak in acronyms, diplomats in measured phrases, scientists in probabilities. Glenn listens, pen poised, then sketches a single line beneath their arguments. We must prove that power can serve life more than fear. When silence follows, he raises his eyes and meets each gaze with steady resolve. Debate resumes, softened now by the weight of conscience. Spring blossoms along the tidal basin as negotiators in Geneva inch toward a partial test ban treaty. Drafts shuttle nightly to Glenn's desk. He studies tables of strontium-90 drifting through milk supplies, iodine-131 lodging in children's thyroids. The figures tighten his chest. The choice is clear. He briefs Kennedy in the Oval Office, voice firm yet quiet, urging an end to atmospheric detonations. The president nods, fingers drumming the resolute desk. Months later, signatures dry on parchment, and for the first time in 2 decades, the sky itself breathes easier. Inhale slowly. Feel any lingering tension loosen like knotted thread. Exhale unhurried. Yet stewardship extends beyond treaties. Glenn commissions long-term studies on radiation workers, wheat fields downwind of test sites, newborns in distant counties. He answers midnight calls from journalists probing reactor incidents, then dawn calls from farm wives asking why the Geiger counter in their pantry clicks at breakfast. Each question receives the same deliberate care, whether uttered beneath chandeliered ceilings or between rows of corn. Autumn arrives with cool rain on Capitol Dome copper. One Tuesday afternoon, Glenn slips away from hearings to visit a 5th-grade classroom in Arlington. Chalk dust floats in sunlit beams as 20 wide-eyed students crowd around a hand-sized plastic model of the atom. Glenn kneels beside them, tie tucked between buttons, and shows how protons cling, how electrons whirl like tiny planets. A girl with braids asks whether new elements might power spaceships to Mars. Glenn smiles, remembering his own train ride west so many years ago, and answers that imagination is often the first fuel any journey needs. Breathe again, steady, light. Let thoughts settle like falling leaves. Tragedy strikes that November. A nation kneels in grief. In quiet rooms draped with black crepe, Glenn pages through unfinished briefing folders stamped for Dallas. He writes a note of condolence to Jacqueline Kennedy, then turns to a new president who greets him with a firm Texas handshake and a mandate to press onward. Under Lyndon Johnson, the commission expands civil power reactors, funds isotope medicine, and launches snap-powered satellites glinting above the clouds. Glenn signs each authorization with careful script, aware that every capsule extends the reach of both promise and responsibility. Evenings find him at a modest desk lamp, drafting a children's booklet titled Understanding Atoms. Simple diagrams flow from his pen, orbital loops, chain reaction dominoes, curved arrows showing how cobalt-60 can chase cancer cells. He mails the proofs to teachers who once sheltered under duck and cover drills. They reply with bundles of crayon drawings, atoms rendered in bright looping rainbows. Glenn pins them on his office wall, a gallery of hope that softens policy briefings with silent color. One winter's night, after yet another Senate hearing on non-proliferation, Glenn strolls the icy path along the reflecting pool. The Washington Monument soars above him, mirrored in dark water. He stops, breath clouding, and pictures an invisible monument beside it, a column built of every isotope humankind has coaxed from the furnace of stars. Some glow for seconds, some for centuries, yet each bears a human fingerprint, proof that knowledge cannot remain neutral. It leans always toward the hearts that wield it. Draw one last breath, deep, unhurried. Feel the cool night air clear your mind, leaving only quiet resolve. In 1971, after a decade of midnights and dawns, Glenn hands the gavel to a successor and returns to Berkeley. Reporters ask what legacy he carries home. He replies not with reactor counts or treaty clauses but with a a child lifting a stone to moonlight, wondering what energies sleep inside. If future generations inherit that same wondering gaze, and inherit a world where atoms brighten hospitals more often than horizons, then his stewardship will have been enough. Let that thought accompany you toward rest. A soft lamp of curiosity glowing on a well-worn desk, its light steady, its promise enduring. Night shift to Mendelevium. February night hushes the Berkeley campus in 1955. Yet inside the old rad lab a thrum of power threads the darkness. A chain of vacuum pumps purrs behind concrete shielding while Glenn Seaborg and 3 weary colleagues pace the control gallery. For 9 unbroken hours a beam of alpha particles has hammered a speck of Einsteinium no larger than a pinhead, chasing a goal almost absurd: to forge an element that may exist only a dozen atoms at a time. At 3 a.m. the beam finally clicks off, leaving an electric silence. The team removes a catcher foil with tweezers and begins a sprint of chemistry so delicate it almost feels like prayer. Solutions flow through columns narrower than knitting needles. Eluted drops flash emerald under ultraviolet lamps. On a tiny mica disc, they mount the residue and slide it beneath a detector. The oscilloscope trace jumps. First one pulse, then a second, spaced like distant lighthouse beams. Enough. They have netted perhaps 17 atoms of a substance unknown to the Earth's crust. Glenn leans against the doorway, shoulders sagging with relief. Around him, smiles bloom slow and incredulous. Someone whispers, "We did it," and the words seem to hang in mid-air, brighter than the fluorescent tubes overhead. Take a relaxed breath, draw it in softly, then let it drift away. Allow your own racing thoughts to settle into the calm of shared discovery. At dawn they pile into a battered sedan and roll downhill to a 24-hour diner whose neon sign still flickers from the war years. Coffee steams into chipped mugs. Exhaustion sweetens every sip. On the back of a paper placemat Glenn sketches the periodic table, slipping the new square beneath fermium. He writes Mendelevium, honoring the Russian dreamer who first arranged the elements by unseen order. Grease stains blot the ink, but the gesture feels official enough until journals catch up. A waitress refills cups, curious about the impromptu artwork. Glenn merely smiles and says they're celebrating a birthday. She laughs, unaware that the guest of honor weighs less than a snowflake and will vanish to half its strength before tomorrow's sunrise. Later that spring, newsmen crowd a press briefing, pencils poised for dramatic numbers that never come. There is no practical scale, no glowing vial to brandish. Glenn tells them the value lies elsewhere, in the proof that even the heaviest anchors of matter can be gently nudged outward, rung by unseen rung. Some reporters shrug, others jot headlines about ghost atoms. Glenn is content either way. The table has inched forward, and with it the reach of human curiosity. Exhale slowly now, as if releasing excess light from the mind, keeping only a quiet ember. Back in the lab months later, he redirects the cyclotron toward medical promise. Americium seeds will guide surgeons to hidden tumors. Curium's heat will power pacemakers. Californium's neutrons will probe the heart of stars inside distant spacecraft. In meetings with NASA engineers, he traces decay curves beside rocket trajectories, linking the pulse of an isotope to the arc of a Saturn V. Some nights he returns home too late for supper, pockets clinking with coin-sized beta badges. He stands on the porch, watching fog curl through eucalyptus branches, and imagines a future classroom on Mars where children recite element names that today rest only in his notebooks. The thought eases him toward sleep. Draw one final breath, deep, unhurried. Feel it carry the wonder of 17 invisible atoms and the vast horizons they suggest. Let that wonder settle over you like the faint glow of a diner's neon sign in pre-dawn stillness, steady and reassuring, as the periodic table waits for dawn to reveal its next unanswered square. Seaborgium and the quiet glow of legacy. Late summer light washes over the Berkeley foothills in 1994, turning lab windows to sheets of pale gold. Glenn Seaborg, walking slowly now yet eyes still bright, pauses beneath the familiar arch of the old rad lab entrance. Inside, a celebration is gathering momentum. Physicists stream past with camera cases and lab notebooks, whispering about cross-section counts that have finally cleared every doubt. Element 106. Born years earlier in overlapping flashes of nickel ions and lead targets, has survived each review. The discovery is his team's, and today they will propose a single unprecedented name: Seaborgium. Take an easy breath, gentle in, soft out, and let the warmth of late afternoon settle across your shoulders like sunlight through an open window. He enters the auditorium to modest applause that swells when colleagues notice him in the doorway. A banner strung between chalkboards reads "Welcome home, Glenn." Next to the podium stands a rolling periodic table taller than any person in the room, a blank square printed beneath tungsten waiting for a label. Graduate students hover beside it, markers poised like quills ready to sign a charter. Glenn's steps are unhurried. Each carries decades of discovery, debate, and sleepless curiosity. At the microphone, a young researcher recounts the evidence in crisp, eager tones: decay chains, half-lives, alpha energies that match theoretical fingerprints. Glenn listens, one hand resting lightly on the table's edge, feeling the faint vibration of whispered excitons in the metal beneath his palm. When the speaker finishes, the hall falls silent and all eyes turn to him. He simply nods and writes 6 letters across the waiting square. G. The strokes steady despite the tremor of age. Applause breaks like gentle surf, rolling forward, then receding into a hush filled with quiet awe. For the first time in history, an element bears the name of a living scientist. Breathe again, slowly, allowing that hush to drift through you, smoothing the day's sharp corners. The years that follow unfold not in accelerators but in classrooms, conferences, and letters from children who tape coin-sized isotopic decals to their bedroom walls. Glenn answers each in tidy cursive, enclosing photocopies of the table with the Actinide row marked in highlighter. On weekends, he volunteers at the Lawrence Hall of Science, guiding small hands toward cloud chamber trails and softly ticking Geiger counters. Whenever a child gasps at the first glimpse of an ion's fleeting thread, he smiles, recognizing the same spark that once lit an iron mine evening in Eishpeming. Autumn 1997 brings official word from the International Union of Pure and Applied Chemistry. Their final vote affirms Seaborgium. At a modest backyard gathering, neighbors string fairy lights between apple trees while former students lift a toast of sparkling cider. Glenn, wrapped in a cardigan against the chill, lifts his glass and says only, "May knowledge outpace our fears, and may wonder forever outrun certainty." The words float into night air scented with crushed leaves and wood smoke. Pause for one more breath. Feel it draw in crisp and cool, then flow outward, carrying with it any lingering weight. In quieter hours he revisits his notebooks, margins crowded with arrows and looping corrections. Some pages bear small water rings from decades-old coffee mugs. Others hold yellowed news clippings, treaty signings, satellite launches, lifesaving isotope therapies. He turns each sheet with care, then closes the cover and gazes at the moonlit outline of the Golden Gate beyond his study window. Somewhere out past those lights, space probes sail on plutonium-warmed hearts, and hospital wards hum with Americium detectors keeping watch through the night. The elements have found their stories. On a bright April morning in 1999, the university invites Glenn to sign a wall-sized periodic table newly installed in the freshman chemistry hall. Students line the corridor, phones held aloft, as he writes his initials beside G, and then, with the flourish of a teacher who never stopped teaching, circles the entire Actinide row. He turns to the crowd and quips that every blank space is an invitation, not an ending. Laughter ripples forward. Pens scribble notes that may one day seed new discoveries. Let that image guide your final breath, steady, unhurried, into a place of gentle calm. Evenings grow shorter as the century's edge draws near. Glenn sits on the back porch with his wife, Helen, watching Orion climb above the redwoods. In the hush between cricket songs, he imagines a distant future where element 155 glows softly in a researcher's palm, and a child somewhere still lifts a stone to moonlight, wondering what silent energies hum within. He closes his eyes, hearing the faint echo of cyclotron magnets and railroad wheels, sensing the table's steady march across the cosmos. Allow that steady march to lull you now. The squares are filled for the moment. The chalk has paused. The night is kind. Drift gently beneath a sky of elements, where each star is a silent promise that curiosity, like the universe itself, has no final border. Elemental echoes and sleep descent. Night has settled across the Berkeley hills, weaving silver threads through eucalyptus leaves and drawing a quiet veil over the laboratories where cyclotrons once roared. Within his study, Glenn Seaborg's favorite leather chair sits near a tall window, its worn arms polished by decades of long evenings spent revising papers, answering letters, and dreaming forward. On the side table rests a single object, a laminated card no larger than a bookmark, printed with the periodic table of 1999. It contains 106 squares, the last of them marked Seaborgium. The card catches a sliver of moonlight and glows with a faint, even pallor, as though the elements themselves are exhaling after a long day of holding the universe together. Take a gentle breath. 4 counts in, brief pause, 6 counts out. And imagine that light breathing with you, expanding and contracting in perfect silent rhythm. Glenn lifts the card and studies it one final time. Not to memorize but to remember. Each symbol stirs a memory. H for hydrogen released in tiny sparks during a boyhood chemistry set. Fe for iron dust mornings in Eichpeming. CF for Californium bubbling behind thick glass while graduate students laughed in nervous wonder. His finger traces down to the actinide row, PA-U, and stops at the delicate curve of AMCMBK, CF. He smiles, recalling the night in a Washington hotel when Americium first flickered like a quiet constellation in a porcelain dish, and the dawn that followed, when newsreels broadcast images of people dancing in Times Square to celebrate an end of war he knew would never be quite complete. He sets the card beside a fountain pen and leans back, letting his eyelids rest half-closed. Outside, the wind shifts, lifting the faint scent of Pacific salt across the valley. A distant train horn drifts up from the freight line, its lonely note sliding slowly over the hills. Glenn's breath matches its rise and fall. Slow inhale with the horn's approach, slower exhale with its fading echo, until the sound becomes a corridor through which memory walks unhurried. In his mind he revisits a November afternoon at Cape Canaveral, standing on a gantry platform while technicians prepared a Voyager probe bound for interstellar space. The bustle hummed with checklists and radio chatter, but Glenn's attention fixed on a gold disc bolted to the craft's flank, a phonograph of humanity's sounds and greetings, etched with a map of our sun's neighborhood and a diagram of the hydrogen atom. He had provided a suggestion, almost whimsical then, that the record also include the modern periodic table, a small, neat engraving of ordered squares to tell any finders that we, the children of one ordinary star, had learned the alphabet of matter and given every letter a name. He watches the memory unfold as the rocket ignites, the flame blooming white and flawless against a blue Florida sky, lifting our message on a pillar of light toward unimaginable distances. Another slow breath. Allow it to travel the length of your spine, loosening each joint, then dissolve into the cushion beneath you. Let the image of that rising rocket drift higher, until it becomes a tiny ember swallowed by the vast dark. Back in the study, Glenn opens a thin journal embossed with a university seal. The pages are blank save for the first line. Notes for the next generation. He considers writing something profound, perhaps advice about patience or the necessity of both caution and courage when unlocking the nucleus. Yet the pen hovers over paper without moving. Some lessons, he decides, must be discovered, not transferred. Instead, he writes a single question. What will the children of Americium teach the children of hydrogen? The moonlight strokes the wet ink, and the question gleams like a dewdrop caught at dawn. He sets the journal aside. In the hush that follows, he hears Helen's gentle breathing from the next room, steady and sure, an anchor in the quiet tide of memory. The clock on the mantel ticks with the soft assurance of an old friend, marking seconds that feel rounded, generous, unhurried. For a long moment he contemplates the equal grace of endings and beginnings. The way a supernova's demise seeds new worlds, the way a scientist's last paper may spark a freshman's first experiment. Every conclusion is a comma, not a period. Feel that thought settle into you like a soft blanket. Follow its texture with one more breath. Deep in, hold, long out, then release it to mingle with the night air. He closes his eyes fully now. Behind the lids blooms a vision of the periodic table unfurling across the cosmos. Each element, once confined to textbook columns, becomes a pinprick star. Hydrogen swarms through nebular clouds. Helium dances at the hearts of red giants. Carbon weaves diamond skeletons of distant planets. Farther out, Americium and Curium flicker in secret, slow decays that warm exoplanet cores. And on the faintest edge Seaborgium glows, scarce, fleeting, yet defiant proof that intelligent life once reached beyond its cradle to sculpt matter itself. As you witness this vision alongside him, draw a breath as wide as the sky. Imagine its cool expanse filling your ribs, then ebbing away like a gentle tide, carrying any remnants of tension with it. The train horn sounds again, farther now, woven into a hush of crickets. Glenn's hands relax, palms open on the chair's arms, fingers curled loosely toward the floor. He cannot know how many generations will pass before another human adds a new row to the table, or whether they will stand on Earth, Mars, or some moon of a star not yet catalogued. But he is certain of one thing: curiosity will persist, because matter itself whispers questions to anyone willing to listen. He imagines a child centuries ahead, leaning over a school desk of transparent alloy, tracing the name of element 170 with a fingertip. Perhaps that child will smile with the same delicate wonder Glenn felt at 12 years old when he first glimpsed the shimmer of hematite under an eisbeaming street lamp. Perhaps, too, the child will pause, humbled by how much patient collaboration lies inside each new square, by how each symbol is not just an atom, but the sum of thousands of midnight coffees, chalk dust debates, and quiet moments of doubt overcome. One last slow breath. Let it be the deepest yet. Inhale through the nose, feel ribs expand, pause. Exhale through slightly parted lips, as though blowing across the surface of cooling tea. With that breath, allow gravity to lengthen your limbs, weighting them comfortably into the mattress or chair. The study grows dimmer. Clouds have shifted, veiling the moon. In that soft dark, the laminated card on the table no longer reflects light. It now seems inwardly lit, as though each element glows with its own patient flame. Glenn's head tilts to one side, chin resting upon his collarbone, and his breathing drifts into the slow cadence of dream. The periodic table beside him, silent, ordered, promise-laden, keeps watch. You too may surrender now to ordered quiet. Imagine the elements arranging themselves around you like gentle guardians. Hydrogen at your brow cooling stray thoughts. Oxygen at your chest deepening each breath. Magnesium easing muscles. Selenium polishing dreams. Feel them standing in calm ranks. Every atom a sentinel murmuring lullabies forged in ancient stars. Beyond the walls, Voyager continues its outward flight. Gold disk trembling in cosmic dust. The rocket's roar is long gone. Only the whisper of solar wind accompanies its silent glide. But the disk still carries those neat squares, a crystalline song of structure and wonder. And one small square etched reminds whoever finds it that in a corner of the Milky Way there once lived a boy who asked what else lay hidden, and a man who helped the hidden melt into view. Let that whisper guide you across the threshold of sleep. No sudden plunge, only a gentle slip, like drifting out on a calm lake beneath steady constellations. Each breath lengthens, soft as velvet. Each heartbeat settles into a slow choreography with the turning earth. The room, the house, the city recede. What remains is a starlit map of elements tracing contours of infinite possibility. And in its cool, ordered glow you are safe to wander the quiet country of dreams. Good night.